Have you ever wondered how your brain stores the memories of your first kiss, your graduation, or even yesterday's breakfast? It's a question that has fascinated scientists and philosophers for centuries. You see, memory isn't just a repository of our past, it's a dynamic process that shapes our present and influences our future. We rely on memory to learn, to communicate, to understand the world around us. Yet the brain's method of storing and retrieving these memories is one of the most complex processes in the universe. Despite this complexity, scientists have managed to decipher some of the basic mechanics of memory storage. They've discovered that our brain, this intricate 3-pound organ in our heads, is like a vast and elaborate library. It's filled with countless books of memories, each one as unique as the experiences that shape us. Our brain, an intricate organ, holds the key to our past, shaping our present and future through memories. Storing a memory in the brain is like saving a file on your computer. But instead of a hard drive, we have neurons. Yes, neurons, those tiny nerve cells that form the basic building blocks of our brain. When we experience something new, our brain fires up these neurons, creating a pattern of neural activity. These patterns are like the binary code of our brain's computer. But how do these neurons communicate? Enter synapses, the microscopic gaps between neurons. When one neuron fires, it sends a chemical signal across the synapse to another neuron. This signal is carried by neurotransmitters, the brain's version of email attachments. The more often a particular pattern of neurons fire and communicate, the stronger the connections between them become. This is how your brain saves a memory. But that's not all. Our memory storage process can be broken down into 3 stages: encoding, storage, and retrieval. During the encoding stage, our brain takes in information from our senses and transforms it into a form that our brain can use. It's like converting a document into a PDF before storing it on your computer. Next comes the storage stage. Here, the encoded information is maintained over time. Think of it as saving that PDF on your hard drive. Finally, we have the retrieval stage. This is when we access the stored information and bring it into consciousness. It's like opening that saved PDF when you need it. This process might seem complicated, but remember, your brain is doing this all the time without you even realizing it. Whether it's remembering a childhood memory or the name of that new colleague at work, your brain is constantly encoding, storing, and retrieving information. So in simple terms, our brain codes, stores, and retrieves memories just like a highly sophisticated computer. Now that we know how memories are stored, let's recap the key points. Our brains, intricate as they are, store memories through a fascinating process that's as complex as it is captivating. At the heart of this process are neurons, the nerve cells in our brain. These billions of neurons are interconnected in a vast dynamic network, communicating through synapses. These junction points where neurons exchange information are vital to memory storage. Changes in the strength of these synapses, a phenomenon known as synaptic plasticity, is the very basis of memory formation. The storage process of memories in our brain is typically categorized into 3 stages: encoding, storage, and retrieval. During encoding, the brain converts a real-world experience into a construct that can be stored. This process involves perceiving something in the outside world and transforming it into a memory. Once encoded, the memory then needs to be stored. This is where the real magic happens. The brain, specifically the hippocampus, consolidates the memory, making it more stable. Then comes the final stage, retrieval. This is when we recall or use the memory. The brain retrieves the memory trace from its storage site and replays it. This is not a simple playback, though. Each time we retrieve a memory, it becomes malleable, subject to change and reinterpretation. This dynamic nature of memory retrieval is why our memories are not always a perfect record of past events. All these processes are not isolated events, they are interconnected, forming a continuous cycle of memory formation, storage, and retrieval. This intricate process shapes our experiences, our learning, and ultimately our identities. Our memories influence our perceptions, our actions, and our future learning. They color our past, present, and future. They make us who we are. In essence, our memories make us who we are, and understanding their storage process helps us appreciate the marvel that is the human brain.